That gap separates today's best models from OpenAI's next big leap. Their current flagship is already running on Cerebras hardware. Picture writing a full novel by hand. Now picture dictating it to a scribe who keeps up with your thoughts. The speed that actually makes people do a double take is 750 tokens per second. OpenAI hosted a government-coordinated preview on June 26, 2026. They pulled back the curtain on their entire next-generation model family. OpenAI announced their upcoming flagship will deploy exclusively on Cerebras wafer-scale silicon. This hardware choice is the real breakthrough. The real headline isn't the models themselves, it is exactly where the flagship tier will run. This breakthrough turns the usual speed limits of large language models into a historical footnote. We need to step back from the usual AI hardware talks to understand why this matters. Most people know GPUs as the workhorse chips powering today's models. GPUs are fantastic, but they were built the traditional way. You design a single processor, die, then slice it into separate chips and bolt them to a motherboard with high-speed cables. Data has to race back and forth across those connections, and that creates serious latency and bottlenecks. Even with excellent phone lines, sharing a single reference book still requires one person to walk to the library, grab it, and bring it back. Picture a team of researchers working in separate offices. They can only share information by physically passing notes across the hall. Cerebras throws the old playbook out the window and builds an entirely different kind of architecture. You heard that right. One solid sheet of silicon roughly the size of a large pizza holds tens of billions of transistors and hundreds. They skip the crowded circuit board entirely. Instead, they print a complete processor directly across one massive silicon wafer. Hundreds of gigabytes of on-chip memory. There are absolutely no discrete chips routing data between them. There are no motherboard traces slowing things down either. Compute and memory share the exact same physical space. They talk to each other at the speed of light across that silicon. Let's quickly reset what a token actually is. In LLM terms, a token is never a full word, but just a fragment. The word running might easily count as one token. At 750 tokens per second, you generate 3 to 4 full words every single second. That figure is just a rough average because the model never stops. Even unbelievable might split into 3 pieces. The system streams everything continuously rather than in bursts. That speed fundamentally changes complex reasoning chains and multi-step coding. Live collaborative writing instantly transforms the experience. Right now, the fastest consumer AI feels like a conversation with a thoughtful but deliberate friend. You type a prompt and hit enter while watching a progress bar crawl or dots bounce. The model quietly figures out its next move. That interruption kills your momentum. At 750 tokens per second, the model never stops, it just streams. You can interrupt it naturally, pivot mid-sentence, or watch it generate a full technical report while you skim ahead. It shifts AI from a tool you query to a workspace you inhabit. More importantly, this speed unlocks practical workflows that were completely impossible before. Get real-time tutoring that adapts to your exact confusion point. Run live data analysis and ask follow-up questions as the chart renders. Interactive storytelling bends the narrative to your choices without loading screens. Your moves change everything. Forget making the model smarter in a vacuum. The real win comes from stripping away the friction between your intent and what the machine actually outputs. Traditional AI hardware hits a wall that has nothing to do with chip speed. The real bottleneck is how fast data travels to and from those processors. We are stuck moving information instead of computing it. That blistering speed comes down to memory bandwidth and data movement across your chips. Silicon cores just shuttle data at lightning pace. When those parameters live off-chip in separate memory modules, the system burns a significant chunk of time just shuttling data back. Modern LLMs are massive because they must hold millions of parameters in memory while processing your prompts. That constant data shuffle creates a serious bottleneck. That bottleneck is the compute stall. It drags out every inference step until the system feels sluggish. Cerebras fixes the problem by placing hundreds of gigabytes of high-speed SRAM directly on the wafer. That memory sits right next to the compute units. Standard servers rely on slower DRAM chips scattered across the board. SRAM beats that speed and stays perfectly co-located. Think of a professional kitchen during a dinner rush. Every tool sits within arm's reach so nothing slows down the cook. Traditional AI chips operate like a row of isolated pop-up food stalls. Every stall runs its own stove and prep space while funneling all ingredients through a single narrow alley. Call for fresh onions. A runner must trek back to the central pantry, wait in line, and haul the supplies forward. The entire kitchen hits a hard speed limit dictated by that corridor. Cerebras flips the model with a single open-plan kitchen where the whole building functions as one continuous prep station. The pantry, stoves, plating area, and servers all share one single counter. The ingredients are already sitting right at hand. The chef reaches, grabs, and cooks without ever breaking rhythm. In hardware terms, that means the model never waits for data fetches. It holds its entire working context inside on-chip memory and streams tokens non-stop. No PCIe lanes. No memory controllers playing traffic cop. Just compute, memory, and data flowing in one unbroken loop. That's exactly how you push 750 tokens per second without melting your data center or blowing past a power budget built for discrete chips. You still need sharper algorithms and cleaner data to make this work. Efficient training runs matter just as much. Blazing fast inference lets developers build systems that lean on massive context windows and complex reasoning chains. They can finally chain those steps together in real time. Raw speed will never rescue a badly designed model. It does completely rewrite your design constraints, though. The real bottleneck snaps back to where it belongs. It lives in your prompt quality and your data pipeline alongside basic safety checks. We deliver real-time tool use without draining user patience or infrastructure costs. We are still working out the guardrails. A flagship model running on Cerebras hardware shows us exactly what happens when we stop treating AI inference like a series of disconnected steps. We are shifting toward a continuous conversation instead of discrete tasks. The models will keep getting better. The underlying hardware will keep evolving. But what happens when we remove the artificial drag between thought and output? That kind of upgrade quietly changes how we actually use the technology. Traditional GPUs waste time shuttling data between separate chips. Cerebras solves this by abandoning discrete components entirely. Standard language models stutter and lag for users. At roughly 750 tokens per second, the user experience completely transforms. You cannot feed that kind of speed from distant memory banks. Placing hundreds of gigabytes of SRAM directly on the processor die keeps the pipeline wide open. Ready to see if you guessed it? Here is the first answer. Motherboards usually force you to juggle multiple discrete chips. Cerebras prints an entire processor across a single full-size silicon wafer instead. This architecture completely eliminates high-speed inter-chip routing, PCIe lanes, and off-chip memory bottlenecks. Your interaction stops feeling like a slow back and forth. It becomes a fluid, real-time conversation instead. We pack massive high-speed SRAM straight onto the wafer. This keeps the model's working context and parameters physically adjacent to the compute units. You can interrupt or pivot midstream without losing momentum. Complex outputs flow out while you stay locked in your creative zone. Long fetch times disappear completely. Tokens stream continuously without a single compute stall. That's the full picture. If this made it click, tap subscribe. There's a new AI explainer here every day. And tap the video on screen to keep going. See you in the next one.